Now we are going to start solving some problems and find the solutions of the problems on indices. There is a number of questions that we are going to solve. This is just the first question, and before we start solving the first question, it's good to review again what we have learned before regarding 9 index laws. So now this is the first 7 of the index laws. Now we can update m and to be rational numbers. So rational numbers include integers. Rational numbers are numbers that can be expressed as a fraction. So for example, if m is an integer, n is an integer, m divided by n, basically that's what we call a rational number. For example, 2 over 3, 2 is an integer and 3 is an integer, positive integer. So 2 over 3 is a rational number. So the reason we can use rational numbers now, because so that is a generalization of m and n, is when we derive the first 3 laws, we start by having m and n positive integers. Then in law number 4, we are introduced with 0 as an index that we can use, provided that we accept a to the 0 equals 1. So m and n can include 0. And then in law number 5, we can have the index to be negative integer. So now we have m and positive integers, 0 and negative integers. In other words, m and n can be integers, positive, 0 and negative. Then in law number 8 and 9, we deal with fractional indices. 1 over n, where n is an integer, so this one is a fraction, what we call a rational number. The same is in law number 9. We have m here is an integer and n an integer, so m divided by n is a fraction, it is a rational number. So we can generalize m and n to include all numbers, what we call rational numbers. So to solve question 1a, it involves division, 4 to the 7 divided by 16, so we are going to use second law here. And then the same for question 1b, 4 to the 7 divided by 8, so it involves division. We are going to use second law. Now question 1c, it involves multiplication and division, so we are going to use the first law here because it involves multiplication in the numerator, and then this number divided by 5 to the 5, so it involves division as well. So we are going to combine these two laws 1 and 2 together to solve question 1c. Now in question 1d, it involves division, so we are going to use the second law here that involves power here. So we are going to use law number 2 and 3. So let's get started. In question 1a, 4 to the 7 divided by 16. 4 to the 7 divided by 16. So a good way is to express, for example here, 4 as a prime number multiplication of prime numbers. So what is a prime number? A prime number is a number that can only be divided by 1, of course, and itself. So I can still break down 4 into 2 squared, 2 times 2. Same as 16. 16 is not a prime number because we can still divide 16 by 2. We can still divide 16 by 4. But 2 to the 4, which is 16, 2 is the prime number. And so we work that out. 4 is 2 squared. Then we have this one to the power of 7. Divided by 16 is 2 to the power of 4. So we have here, it involves two indices here, we just multiply the two indices. And we have 2 to the power of 2 times 7 divided by 2 to the power of 4. So we got 2 to the power of 14 divided by 2 to the power of 4, and then we have 2 to the power of 10. Now for 1b, 4 to the 7 divided by 8. Same thing. 4 is 2 squared, so we express, because 2 is a prime number, 4 is not a prime number, so we express a multiplication of prime number. 2 squared to the power of 7 divided by 8 is 2 to the power of 3. So we have 2 to the power of 2 times 7 divided by 2 to the power of 3, and that equals 2 to the power of 14 divided by 2 to the power of 3, and that equals 2 to the power of 11. For 1c, 5 squared times 5 to the 6 divided by 5 to the 5. So we have all the same base here, 5, 5, 5. We can use the index laws. So that the numerator in for multiplication. So we just add the indices to get the result. So that equals 5 to the power of 2 plus 6, and then divided by 5 to the 5, and that equals 5 to the 8 divided by 5 to the 5, and that equals 5 to the power of 3. So that's for 1c. For 1d, 3 to the power of 6 divided by 3 squared, and to the power of 1 over 2. So we work out this one first. 3 to the 6 divided by 3 to the 2. So we subtract indices, second law. So we get here 3 to the 4, 6 minus 2, to the power of 1 over 2. So it involves the indices. We multiply the indices to get the result. 3 to the power of 4 times a half, and that equals 3 to the power of 2. So it's asking here, simplify, express your answer in terms of positive indices. So we don't need to simplify again to make it 9. So just leave it as it is. It's fine. That's for the first question. We're going to move on to the next question.